Alright, well today's topic is called integration by u-substitution. Now most of the time we'll just refer to it as u-sub, but it does stand for u-substitution. Now there are going to be a lot of steps and we need you to copy these down perfectly in your notebook so you can always refer back to them. So it'll probably take you a minute to pause it and get them in. So step number 1. Set u equal to the part of the integrand, usually a function inside of a function. Okay? And that's the whole key. You need to pick the right u term. Step 2, we need to find du dx. So we're going to take the derivative of u with respect to x. 3, solve for dx. 4, substitute the expression found into dx. 5, simplify the integral so it's in terms of u. Integrate in terms of u. And then substitute the original value of u back into the equation so your final answer is in terms of the original variable. So there's no better way to practice than just to go ahead and get our hands dirty here. So let's try some. Number 1, the integral of the square root of 4x minus 9. Now, let me just remind you why we can't do this. The only way we've learned to integrate so far is if you have x to the n. Then, that is x to the n plus 1 over n plus 1. We've done that for a while, but the whole key to that was, guys, is that you only had one term to a power. Okay, so I cannot integrate this unless it's one term to a power. So that's how I know I need u sub. So the hint was to pick a u, and that's what we're going to jot down, and everybody jots the same thing down. We need to pick a u who's inside of a function. Well, this 4x minus 9 is inside the radical, so I'm going to say u equals 4x minus 9. Look at your steps. The next step says find du. So now I'm going to integrate this function with respect to x. So I get du equals, the derivative of this side is 4 dx. Follow your steps. The next step says solve for dx. So I'm going to say du over 4 equals dx. Following the steps, it now says take what you have for dx here and substitute it into the dx in the problem. So I'm going to have the integral of the square root of 4x minus 9, and in place of dx, that's what I'm putting in here, I'm writing du over 4. Now, the next thing I have to do is I have to get everybody in terms of u. So now I can say this 4x minus 9 was really u. So I have the integral of the square root of u times du over 4. So this is what we call u-substitution. So we picked our u, okay, we took its derivative, we solved for dx, and we substituted into the dx. Now we get our whole function to be in terms of u. Now before I integrate, let's do an easy pull out here. This 4 says divided by 4, so I can pull that out as a 1/4, 4 is on the bottom, the integral of u to the 1/2 du. Now I can use my integration rule, because remember, it had to be one term to the n, and that's what I have here. So now we'll integrate. We'll get u to the, add my 2, is 3/2, either divided by 2/3, divided by 3/2 or times 2/3, plus c. And don't forget you have this 1/4 out front. Alright, so now we'll just carefully clean it up. I'm going to say that's 2/12 or 1/6 u to the 3/2 plus c. Now lastly, if you look at that last step we wrote down, it says take your original u and substitute it back into the equation. So my original u was 4x minus 9, so I'm going to say I get 1/6 4x minus 9 raised to the 3/2 plus c. And of course that's equivalent to 1/6 square root of 4x minus 9 cubed plus c. And we've completed our first u substitution. Now don't worry if it went too fast, we're going to get lots to practice with today. So stay with me and let's try another one. Example 2. So I first need to decide if I need u substitution or not. And again, all I say to myself is, do I have one variable to a power? And certainly not. I have a whole bunch of junk inside here to a power. So I have to use what we call u substitution. All right, so our u, again, is the function that's inside something. That's what you keep saying to yourself. Okay, pick something that's inside something. So I'm going to say this is inside that quantity to the fourth. So I'm going to let u equal 3x minus 1. Okay, so now we go get our du. Du equals, the derivative of that is 3 dx. And I get du over 3 equals dx. Okay, we're going to take that and substitute it into the dx in the problem. So I get the integral of 3. I'll leave this here. Well, I'm going to do another step at the same time here. This 3x minus 1 is going to go in for my u to the fourth. And in place of that dx, I'm putting du over 3. Okay, so I made 2 substitutions. I substituted this u into the dx, and I put my u in here. Now I'm going to clean up just a little before I integrate. This 3 and this 1/3 are going to cancel, and I'm really just integrating u to the fourth du. Now it's this simple rule where we add 1 and divide. So I get u to the fifth divided by 5 plus c. And just remember, you're not done till you substitute the original back in. So my original u here is this 3x minus 1. So I get 3x minus 1 to the fifth over 5 plus c. And there you have it. Now remember, you can always check to see if you're right if you just take this guy's derivative. It should line up to the first one. So I'm going to rewrite it as 1/5, 3x minus 1 to the fifth plus c, and derive it. So I would get 1/5 times 5 times 3x minus 1 to the fourth times 3, and of course that disappears. Those cancel, and I get 3 times that quantity, which of course was that original integram that I was integrating. All right, well, let's see how you've got it. Why don't you pause it, try it on your own, and see if you get the same thing. All right, good luck. Pause it and see what you get. All right, well, welcome back. I've gone all through my steps except the actual integrating step. So remember, I picked the u that's inside something. All right, so this part is inside the radical. That was my u. Its derivative is 3x squared dx. Divide that over, I get my du over 3x squared. Substituted that into the dx, and I replaced this chunk with the u. Now again, if you did it right, things should cancel. Those will cancel. So I'm really just integrating the square root of u, or u to the 1/2 du. So I get u to the 3/2 times 2/3 plus c. And lastly, substitute that original in. So 2/3 times x cubed minus 2 to the 3/2 plus c. All right, hopefully you're feeling in the groove. I want you to try another one. They are going to start to change a little bit. We'll try to do another one that's fairly simple. So identify your u, take its derivative, and go as far as you can. Pause it, see what you get. All right, so hopefully you've identified the correct u, took its derivative, rewrote your dx, and substituted it in. Okay, so my negative 4x's cancel, and I end up with du over u squared. Now again, I'm just going to rewrite that before I actually integrate it. That's u to the negative 2 du. And I'll integrate, what does that get me? U to the negative 1 divided by negative 1 plus c. So I'm going to say I have negative 1 over the u, which is 1 minus 2x squared plus c for my final answer. Now, you might be saying, well, what happens if you pick the wrong u? We'll try this. If I said, let me recopy this. Let's say I didn't know who my u was, and I said, what if I let u equal negative 4x? And I take its derivative, I would get negative 4 dx, so I get du over negative 4 equals dx. Now watch when I do my substitution. I would get u over 1 minus 2x squared times du over negative 4. Is anything canceling? Is this cleaning up nice? No. So if that happens, that's the idea that you picked the wrong u. And again, it should be semi-obvious. It should be something that's inside something. That's usually the key. All right, now here's where it can get a little trickier, especially with the trig functions. We've got the integral of cosine squared x times sine x dx. Now you might be saying, okay, who do I pick? Nobody's inside something. But rewrite it. and that's the trick here. Okay, rewrite it like you would take the derivative. I would say this is the cosine of x squared times the sine of x. Now is it obvious who your u should be? Who is inside something? This is, and when I rewrite it, it makes a lot more sense. All right, so I'm going to say u equals cosine x, du equals negative sine x dx, solve for dx, and I get du over negative sine x. Okay, now we can make our substitution. I'm going to, take this and substitute it into the... Sorry about that, Bailey got a little excited. All right, so I'm substituting that into my du, so I'm going to get the integral of, now remember, cosine is my u, so the integral of u squared times sine of x, and in place of dx, I'm going to put du over negative sine x. Now remember, if you did it right, things should cancel, and of course this sine x cancels with this sine x, just be careful of that negative. So I'm going to say this is the negative integral of u squared du. And that's it. Then we have the easy part, the integrating part. So we get u cubed over 3, watch that negative out front, plus c. And so I'm going to say that's negative, oh geez, what was my u? Cosine of x. All over 3 plus c for my final answer. All right, so again, just be careful who you pick for that u. All right, question number 6. Which of these functions will u-substitution work for? All right, and which one's going to get integrated? So here's the deal. Let's start with option 1. Who would you pick as your u? Okay, remember, pick the thing that's in the function that's inside something. So I'm going to say, okay, let's let u equal x squared plus 1. All right, and we just try it. We'll take its derivative. Du equals then 2x dx. So we get du over 2x equals dx. All right, let's try our substitution. That goes into dx. So I get the integral of x times u squared, and I've got du over 2x. Those nicely cancel, and just be careful, you're pulling out what number if that 2's on the bottom. That's a 1/2 the integral of u squared du. So I would say u-substitution definitely works, and I could go ahead and integrate that. Now let's take a look at this next one. If I try to do u-substitution, I get u equals x squared plus 1. All right, that's pretty easy. Du equals 2x dx. I get du over 2x equals dx. All right, now, again, we're thinking it's working. Let's substitute it in. That's my u. So that's u squared times times du over 2x. All right, now be careful on this. If I try to do u-substitution, I can pull the 2 out because it's a constant, but now I have u squared du over x. Do we know how to integrate something like that? No, and it's not possible. I want to be very clear that that's not allowed. That is not possible, to integrate. All right, so this is where u-substitution fails. All right, so it's not going to work every time. So you have to go back and say, okay, well, how the heck would I integrate that? And you should know, we've actually done this problem before in class. What would your gut tell you to do with this quantity squared? Hopefully just FOIL it out. So it's x squared plus 1. So that's the integral of x squared plus 1 squared dx. All right, all you literally have to do is integrate, and again, I would FOIL it out, x squared plus 1 times x squared plus 1. I would get the integral of x to the 4th plus 2x squared plus 1 dx. And now I can go through and simply apply each rule. All right, but you have to be smart. U-sub is not going to work every time. Things have to cancel for it to work. All right, next little one. This is a great second example here to compare. Which one is u-sub going to work on? This first one versus this one. So I'm going to just practice rewriting it. Do I need u-sub here? I don't think so. I think I can rewrite this as 1/3, okay, integral x to the negative 1/2. And the rule says as long as you have one variable to a power, you can integrate. Okay, so again, I just want to stress, it's x to the n. I can integrate that as x to the n plus 1 over n plus 1, but I can only have one variable there. Watch the second one. If I were to try to rewrite this, I would get 3x to the negative 1/2 dx. Does the integrating rule work here? Is it one term to a variable? Okay, and the answer is no. This is not one term to a variable. You have to do u sub. All right, it does not work. Okay, I can't just integrate if it's not one term there. It's got to be u sub. Another thing I say to myself is if I was to take this guy's derivative, I would need chain rule. Therefore, to integrate, I need u sub. And that might be something you want to star in your notebook. If you were to take its derivative and need chain rule, you're going to need u sub to integrate it. So again, I would jot that down. So let's do a quick u sub here. My u would be the function inside, so 3x. I would get du equals 3 dx. So that's du over 3 equals dx. Substitute it in, I get the integral of u to the negative 1/2 times du over 3. Okay, I can pull out, the 3's on the bottom, so I'm pulling out a 1/3 integral of u to the negative 1/2 du. So that's 1/3 u to the 1/2 times 2 plus c. So that would get me 2/3 u to the 1/2 plus c. And then, of course, you would just take that original u and substitute it back in. So lastly, 2/3 times the quantity, 3x to the 1/2 plus c. All right, we're chugging. We got just a few more to go here. So the integral of tangent cubed x times secant squared x. So again, we said rewrite it so it's a function inside somebody. So I'm going to say tangent of x cubed times secant of x squared dx. All right, so in this case, we have options. We have two functions inside. I could pick tangent or I could pick secant. And this is, again, where you got to be a little mentally sharp here. You can take the derivative in your head and see which one makes more sense. I'll write it out tonight, but eventually you should be able to take it in your head. If I pick u as tangent of x, its derivative is secant squared x. Do you see how handy that is? Its derivative is sitting in your function. Okay, here's secant squared. So to me, that's a winner. If I take the derivative and I see it in my function, that's the one I'm going to pick. However, if I picked u to be secant x, and I take its derivative, I would get secant x tan x dx. I don't have that in there anymore because this is tangent cubed and secant squared. So again, if I can take the derivative and I see its derivative in there, that's the one I'm going to pick. All right, so if I say I get du over secant squared x equals dx, we'll substitute it in. So we get, let's see, that's u cubed times secant squared du over secant squared. Those cancel, and I'm really just doing a nice simple integral of u cubed. So I get u to the 4th over 4 plus c. So that's going to get me tangent of x to the 4th over 4 plus c for my final answer. Okay, so again, I suggest trying to mentally take the derivative, and that will kind of make your process go a little faster. All right, we've made it to the last one for the night, and this one again is another tricky step to it. So let's be careful here. If I were to rewrite this, this says the sine of 5x times the cosine of 5x. All right, so we might be thinking our u should be 5x. That's the term that's sitting inside something. All right, now go with me on what we just said. We said mentally take the derivative. If I said u equals 5x, what's its derivative? 5 dx. Is that going to cancel with anything? No. If I try to substitute that back in, I'm going to get the sine of u, the cosine of u, and du over 5. That doesn't clean anything up. That's useless to me. All right, so here's the rare chance where it's not the term in the parentheses. We have to go a little bigger. I think we're going to have to pick for our u sine of 5x. Okay, now watch what happens when you take its derivative. The derivative of sine of 5x is 5 times the cosine of 5x dx. So I would get du over 5 cosine of 5x. Now, why is that so much better? Well, look at this. 5 cosine 5x, cosine of 5x is in the problem. Remember, you need the derivative to be in the equation. So now let's substitute in. So I'm going to get the integral, that's my u, cosine of 5x times du over 5 cosine of 5x. My cosines of 5x's are going to cancel. And let's see, I'm going to pull that 5 out. Notice the 5 is on the bottom, so that's a 1/5 the integral of u du. So I've got 1/5 u squared over 2 plus c. So that gets me a 1/10. My u is sine of 5x squared plus c. All right, well, there you have it. We finally introduced you to the amazing world of u-substitution, and we'll look forward to a lot of practice tomorrow. Have a great night.